Hi Math 95 students, we're on section 10.3, which is on applications of quadratic functions. So these were all going to be word problems. So the hardest part of these problems will be like writing down the equation that you need to solve in order to answer the question. So in this section, just remember that we're looking at equations of the form like ax squared plus bx plus c, or something of the form like x squared or x minus h squared plus a number, something like that. And we have some methods for solving these types of quadratic equations. One of the methods, if your equation is like in vertex form where you only have one term that involves an x, you can kind of just move everything to one side and try and get x by itself by taking the square root of both sides. That's called the square root method. Let me write that down here. Square root method. Or if you have like two terms that involve an x, then you might either want to factor or use the quadratic equation. But in my experience, I think that actually solving the quadratic is not the hard part of these problems. It's really just understanding the problem and writing down an equation that you can use. Let's look at this first example. The area, so there's a word we need to understand, of a children's rectangular playground is 500 square meters. The length is 5 meters longer than the width. Find the length and width of the playground. So for these types of problems, I really want to start by drawing the rectangle. And usually I use L to represent length and W to represent width. Make sure I know what I'm using. If the area is in square meters, then this is going to be in meters. And length will also be in meters. Okay, so remember that the area is the distance, or not the distance, the area inside of the object. Sort of like if you broke this up into a whole bunch of 1 by 1 square meter squares. How many little squares do we need to fill up the whole thing? So we need to remember that the area of a rectangle is length times width. So I'm going to use that formula because I know that the area equals 500 square meters. Okay, the other thing I'm going to use is this piece of information here. The length is 5 meters longer than the width. So that's that is a relationship between the length and the width. I can just take that whole sentence and turn it into an equation. The length is, so I'll write L equals 5 meters longer than the width. So whatever the width is, I'll add 5 meters to it to get the length. The length is 5 meters longer than the width. Okay, so now let me go ahead and use the area, length times width. But I'm going to use, instead of L, I'll use W plus 5, so that instead of having two different variables in my equation, I'll have just one. So again, I know that length times width, it should be equal to 500 because that was given to me. And instead of L, I'll use W plus 5. So W plus 5 times W equals 500. Now I have an equation only involving one variable, W. Let's go ahead and open up these parentheses. This will give me W squared plus 5W equals 500. Now notice this is a quadratic equation, and it's in this standard form here. So I'm going to move everything over to one side. W squared plus 5W, subtract 500 from both sides, and set it equal to 0. Alright, and then the next thing that I want to do is I can either factor this. I can't think of two numbers that multiply to negative 500 and add to 5 off the top of my head, so I think instead I'll use the quadratic formula. The quadratic formula, usually we use x, but in this case I have w. It'll be negative b plus or minus square root b squared minus 4ac all over 2a. So we need to remember what all these players are. First of all, a is the coefficient in front of the squared term. So a is 1. B is the coefficient of the middle term. So b is 5. and c is negative 500, the constant term. When I'm doing these problems, I really like to calculate the discriminant first. b squared minus 4ac. So that'll be 5 squared minus 4 times 1 times negative 500. And if I put that in my calculator, I get 2,025. Okay, let's keep going with this. So w should equal negative b, so negative 5, plus or minus square root of that b squared minus 4ac that I just calculated, 25, all over 2 times a, which is 1. All right, and I can use my calculator to tell me that the square root of 25 is 45. So I get negative 5 plus or minus 45 all over 2. Okay, and then you can kind of split this up because that plus minus really means two separate things. So w equals negative 5 plus 45 over 2, or negative 5 minus 45 over 2. So in this case, negative 5 plus 40, that's 40 divided by 2 is 20. Or this will be negative 50 divided by 2, which is negative 25. Okay, so now that I have my answer for the equation, let's go back to the problem. What I'm supposed to do is find the length and the width of the playground. I found w. I got two separate numbers for w. Now, saying that w is 20 meters versus negative 25 meters, this negative doesn't really make a lot of sense in the context of the problem because negative length just is preposterous. So what I'll say is that the width is 20 meters, and my directions was to find the length and the width of the playground. So I still need to find the length. So let's go back in the problem. The width is 20 meters. And now to find the length, I'll use this equation right here that says the length is 5 meters more than the width. So the length, I plug 20 in there, 20 plus 5 is 25 meters. Okay, so with these problems, I think the hardest thing is to really understand all the information that's given to you. Drawing a picture helps. Labeling everything in terms of its units also really helps. Usually you're going to use maybe some type of formula, so make sure we write down the formulas that we might need. In all of these problems, in most of these problems, you'll be substituting maybe a relationship between the variables, substitute that into one of the formulas. And then that should lead to a quadratic equation. So you can solve that with any method, but after you solve that quadratic equation, go back to the problem. Make sure that you understand if you get two answers, maybe one of them's not really, doesn't make sense in the context of the problem. And then make sure you go back and does the number that you got from your equation, does that answer the question? Or do you need to do a little bit more work to answer the question?